Welcome everyone to the third week of the tutorial, and this week we're going to be learning about JavaScript. I'm just curious, raise your hand if you do have experience with JavaScript, like if you've written JavaScript before. Okay, it's around like 30–20%. Cool. Okay, so just a quick reminder, core technologies of the web, HTML, CSS, and JavaScript. HTML responsible for the content, CSS responsible for the presentation, and JavaScript responsible for the functionality. So, feedback. Okay, so yeah, if we're learning JavaScript, we are basically implementing functionalities into the website. So what is JavaScript? JavaScript is a programming language, or more specifically a standard that is used to make websites interactive, such as responding to user input. The standard of JS is called ECMAScript, and ECMAScript is updated every few years. The only programming language that runs on the browser, only because before I think there's PHP, but right now it's pretty much the only language that people use that actually runs on the browser. It allows for dynamic content updates without reloading pages, and I think JavaScript is the most popular language in the world, if I'm not mistaken, according to Overflow. Wait, what's the website called? Stack Overflow, yeah. Stack Overflow surveys. So it's a very, very much in-demand language. So, okay, I'm not going to get into that just yet. So because we are learning JavaScript, there's not going to be much content updates on this site. I just want to go over like the basic syntax of JavaScript and sort of running JavaScript, and then maybe we'll have at the end like sort of a little thing that involves JavaScript, but that's pretty much it. So we won't be going over the website a lot, but we will be running JavaScript on the console. So if you just inspect, so you can right click and click inspect, or you can do Command Option I on a Mac. And you'll see here that you can see the elements of the page, but here you have the console. And the console is sort of where JavaScript runs on the browser. So you can actually write JavaScript in here and you'll see the output. So for example, the first thing you should learn in a programming language is printing. So if I want to print in JavaScript, I just do console.log, right? Console is a global object, .log is a method within that object. Let me zoom in here. And then in here, inside the function, I can pass in a string that I want to print out. Wow, it already knows I want to do this. Okay, hello world, right? And then if you run, you'll see hello world. So that's the basics of JavaScript. It runs on the browser. For now, we're going to just run JavaScript on the browser. Later on, you're going to learn about Node and how to run JavaScript on the computer. But for now, JavaScript is running on the browser, and that's what it's originally intended for. So that's pretty cool, but we want to actually write languages or JavaScript on want to write languages or JavaScript on a JS file instead of on the console. So to do that, we can go back to the source code of the website, right? So we have the HTML and the CSS. We're going to create another file called script.js. Script.js. .js because it's a JavaScript file. And then now in here, we can actually type in console.log, hello world. Now if we go back to the page and refresh, nothing happens, of course, because we haven't connected the JavaScript file to the actual website. So to do that, we go back to the index.html. And unlike CSS, where we connect it using a link tag, we're going to have to connect it with a script tag. And it is recommended to do it after the body tag. But it doesn't really matter too much for our scenario. So if you just type in script:source, right? It's a script tag with a attribute of source, and the source will point to the file. So relative to the index.html, the file is script.js. You save that, go back, refresh, and you'll see hello world. So that's the basics of running JavaScript on the browser. We have the script connected to the index.html, and whenever you reload the page, that JavaScript file will essentially run, and the output will be printed in the console. But of course, JavaScript is much more powerful than this, and it can do a lot more. So let me see here. All right, so I'm going to explain the basics of JavaScript syntax. We're going to go over like this part essentially, printing variables, conditional statements, yada, yada, yada. So we already did printing, but let's see how we can create variables. So I'm going to assume some basic programming knowledge here. I assume you guys know Raise your hand if you know Python. Okay, good. Raise your hand if you know Java. Okay, that's really good because the syntax for Java is almost identical to JavaScript, almost. Okay, so to create a variable, JavaScript doesn't really have strict types when you're actually programming. So to create a variable, you write const, and you can say, let's say my num. It uses the Pascal type or Pascal casing, just like Java, and then a number, right? And then you can log it. I'm sure you guys know what's going on here. My num. Save that, go back, refresh, and you see the number, right? So what is this const keyword, right? Const stands for constant, and what this means is that the variable that we're creating is a constant, which means it cannot be reassigned to something else. So for example, if I do my num and I assign it later on to 2, right? That's not allowed because my num is a constant. You go back, refresh, and you'll see an error. Uncaught type error, assignment to constant variable, right? So that's not allowed. So what if you want a variable that can actually change? So if you want a variable that actually changes, instead of using const, we use let. So we're going to change the const to let, save that, go back, refresh, and you see that we can actually change it from 4 to 2, and it actually works. Surprisingly, you'll think that let is more popular, but let is actually less popular, and const is pretty much what you'll be using most of the time. And it's easier to just do JavaScript, and you'll see why. It's very hard to explain, but essentially JavaScript, much of the JavaScript you're going to write is very much React, and React is a very functional type style of programming, and because it's functional, it doesn't really want to mutate variables. Instead of like changing existing variables, they want to like create another, another variable, and then like assign it like in terms of my num, right? So that is the style that you're going to be working with rather than changing existing variables. You're just going to create new ones. So const, just use const like 99% of the times. Only if you absolutely need to use let, you absolutely need to mutate variables, that's what you do. So that's how you create variables. Conditional statements, okay. So conditional statements are very, very similar. So if I delete this, okay. Conditional statement, let's do if. If we have a condition, right? 3 equals to 3. And then you open curly brackets. If any of you have Java experience, I think it looks the exact same. So new line, console.log, hello world. Save, go back, refresh, hello world, right? Because 3 equals to 3. So, and obviously if you change it to 4, it won't run. So in here, in most languages, equals to is just the sort of equality operator. But in Java or JavaScript, what's really weird is, and I'll show you, that if you do 3 equals to the string of 3, it will print. So the number 3 is equal to the string of 3. The creator of JavaScript actually, I think, created JavaScript in like, I think 10 days or something. So it's very like scrappy and just hacked together. It's improved a lot over the years, but this is sort of like a relic of that sort of, it used to be called the toy language. But anyways, to sort of fix this, most of the time, 99% of the times, you'll be using equals to. So yeah, I know, it's a lot of equals, but that is essentially how we can get rid of the weird behavior. Now if you go back, it won't run, right? So now, whenever you want sort of to specify that two things are equal, you have to make sure that you're using the strict equality and not the equals to. The equals to, you just basically never use it. So, all right, so that's equality, conditional statements, and then, so obviously with else, it's the same thing as Java, else, console.log else statement, right? So if this doesn't run, which it doesn't, it will run the else statement. So if I go back, refresh, that's the else statement, right? Else if, same thing, else if, and then your condition, and this condition can be another condition, so 2 equals to 2, and this is the else if statement, right? And then in here you can type the else, right? So this will run else if, and it will not run else, right? But if this is wrong, or this is false, then else will run, right? The syntax is, I think, basically the same as Java, but if you're coming from a language like Python, one thing that you have to get used to is these curly brackets. Essentially, instead of using indentation, we're going to use curly brackets. So and every single condition needs to be wrapped in a parentheses, and that's not a thing in Python. So that's conditional statements. Let's do loops. Loops also pretty similar to other languages. So if we do for loops, right? Let's do let's do while loops first. While, and then a condition, right? So let's just do true, just for it to run forever. Console.log, hi. Save that. This should run hi forever, right? So if I go back, I refresh, and we have lots of highs. I believe this will actually stop the page from loading. You'll see here that the page actually has a lot of glitches. In fact, it's glitching a lot. So if you ever want to freeze your friend's browser, you go in their console and type in while true, and it will just freeze. I think that will work, actually. I'm actually curious. I can't refresh now. Why did I do this? Why did I do while true? I'm gonna save the link, go back. Okay. Oh, this is still lacking. I regret my while true. Okay, I'm not gonna demo the next one. Okay, so for okay, so if you're coming from Python, this will be very confusing, but if you're coming from Java, this is exactly the same. So for, you're gonna type in for, and in parentheses, and you're gonna say let I equal to a number, let's say 0, semicolon, and then you're gonna say I less than a certain number, let's just say 5, semicolon, and then a condition for the loop to stop. So, sorry, okay, I'm gonna explain this. This is the variable that sort of keeps track of the for loop. So you can sort of like, in Python, you can sort of think like for I in range, right? The I is the I in the let I. So this is the counter for the for loop. I'm going to initialize it to 0. So initially it's going to be 0. I can initialize it to 1, and initially it's going to be, on the first iteration, it will be 1, right? But in this case, the first iteration will be 0. This condition is the condition at which it stops. If this is true, it will keep running. If this is false, it will jump out of the loop. So basically, while I is less than 5, it will keep on running. And this plus plus is an operator that increases the variable by 1. So I plus plus increases I by 1. And this is the thing that will run after every single iteration. So it will start with having I be 0, and then after every single iteration, it will increase I by 1, and then the whole loop will stop if I is less than 5. So that's how the for loop works. So the console.log hi here. Okay, so it will run 0, 1, 2, 3, 4, and then when it gets to 5, because 5 is not less than 5, it will just not run. So it will go from 0 to 4. If I go back, my browser has crashed. I did not know while true is this powerful. Sorry, hold on. I think it's this one. Yeah, okay. Yeah, so, sorry. Instead of printing hi, I want to print I, just to make it clear. Yeah, print I, so print from I from 0 to 4. Refresh, 0 to 4, right? So that's for loop. If you want to go like, if you want to like loop through the indexes of an array, right? So if I do const my array equals to 1, 2, 3, 4, right? You can sort of imagine that it's the same thing. Let I equals to 0, I actually stands for index. And then you have my R, and if you get the length of the array, the length, right? So every single I will be an index in the array from 0 all the way to 3. All right, so that's for loop. Now I got to open up the topics again. Okay, we got loops, and then let's do functions. So functions in JavaScript. To write functions, we do, actually functions is the most complicated part, but let's do function, and then let's say add, and then we take in an x and a y, curly brackets, and then we can console.log x plus y, right? Or maybe a more standard way of doing it, return x plus y, right? So I'm assuming you guys know what function does and what return means. So this is a function that takes in two variables, x and y, and it returns their sum. So now in here I can type in console.log, and you'll see, you'll know, right? Add 2, 3, refresh, and you get 5, right? So not very complicated, right? The function keyword and just type in your function. Now the reason why I say the function is the most complicated is because there's actually two ways of creating it. One is declaration, which is sort of what you're used to. This is declaration. Another one is expression. So you can essentially write your functions as an expression, and functions in JavaScript are first-class citizens, which means you can actually throw it around as if it's a data type. So you can actually assign it to a variable, and that's what we're going to do. So we're going to do const add equals to function x, y, return x plus y. So if you've never done JavaScript before, this will look very wonky, but you can sort of kind of make sense of this. We are assigning the variable add as the function. And then if you save this, go back, refresh, it will print the same thing. Now you'll notice that this function is nameless. It doesn't really have a name. That's because I'm assigning it to a variable, so I'm going to use that as the name. But you can actually have another name, so name, I guess. And it does work too. But you'll see that you actually can't use the name as the name because you're not declaring it as a function. So this just gets confusing. I would just recommend using the nameless one. And so this is one way of writing function declaration, is using function, or function expression rather. Another way of writing it is through arrow functions. Yeah?
How is that going to, like, how would that be useful for you?
This?
Like having the function be like assigned to a variable?
That's actually a very deep JavaScript concept. I think I learned it, but I forgot about it. For now, it's not that useful, but I think it's best practice. A lot of people do this, but nameless functions and anonymous functions, they're actually very useful, and you'll see why in a bit. But for now, I would say just write your functions like a normal person, like this, or assign it to a variable. Like, that's totally fine. But another way of writing functions, and you'll see this a lot, is you just write the parentheses and you type in an arrow afterwards and then curly brackets. So these are called arrow functions, and they're for the purposes of right now, they're essentially the same, and I'll get over the slight differences in a bit, but they're basically the same thing. So const add equals to the function that takes in x and y, which returns x plus y, right? So instead of the function keyword, we just use the arrow. And you go back, you refresh, and you'll see that it's the same thing. So arrow functions are something we're going to use a lot. In React, you're going to see why in a bit, but for now, just know that this is just another way of writing anonymous functions. This is just another nameless function. Okay, so that's functions. You can use this, you can use this. It doesn't really matter for now. But just don't get confused when people are using different things. All right, data types. I'm not going to go over too much about data types, but we have strings. I'm sure you know what that is. Number, which is integer. We actually don't have like different kinds of numbers. It's just, in JavaScript, it's just numbers. There's no like floats or int 32 or whatever. And then objects. So let's talk about objects. If you've done Java before, you won't be too confused. But if you have never done Java before and you've never done object-oriented programming, it's going to be very confusing. So hopefully you guys know a bit of object-oriented programming. So let's do objects. Actually, raise your hand if you know what objects and classes are. Okay, that's good. That's good. Okay. All right, so let's create an object. Unlike Java, let's do person. So unlike Java, we can actually create objects from scratch. We don't need a class. So to create an object, we just do curly brackets, and in these curly brackets, I'm going to write the property and then the value, right? So name equals to John, comma. Sorry, not equals to, but colon. Name colon John, age 20, delete that, okay. So now we have an object, attribute name is John, attribute age is 20. If I log person, save, go back, refresh, The console is pretty smart. It won't log the actual reference to the object. It will actually log the attributes. So we have name, John, and age 20. So that's pretty cool. So that's one way of creating objects, is just creating it raw. But you'll see that that is sort of a, for now it's not too big of an issue, but if you're creating big applications, you might want to have classes, or at least know that certain objects are similar to each other, or have extremely similar, or actually the same attributes. And later on, you would want to do like something like inheritance, where certain objects have every attribute plus some, right? So to do that, another way of doing it is through constructor functions, using the this keyword. So I'm going to comment this out. Another way of creating objects is creating a constructor function. Again, we don't need classes, we just create the function. So we're going to do function, and I'm going to type person, right? I'm going to capitalize it because this sort of acts like a class. I'm going to take in a name and an age. And then we're going to do this.name equals name, this.age equals age, right? Exactly like a constructor function in Java. So I'm taking in a name and age, and I'm assigning the object's name to the name and object's age to that age. Okay, now let's create the object. So to create the object, we're going to do const John equals to new, exactly like Java, person, name is John, age is 20, save. Okay, so now we have the John object. We can log the John object. Go back, refresh, and you'll see same thing, right? But the only difference is that now you can create another one, right? So you can create another object and then use the new person again, right? So this is a bit weird, because how does it know that this is the object? And how does it actually return that object? So if you actually just not have this new here, right, and just delete that new, it won't work. So John is nothing. And the reason why you need that new is because when you do a new and then you call the constructor function, it will treat the constructor function as a constructor function. Nothing about this function makes it a constructor function other than the fact that it is meant to be used by calling it with the new keyword. So it's very, very hacky. And so if you call a function with a new keyword, it will treat that function as a constructor function. And when it does that, it will assign the this keyword to the object to be returned, and it will automatically return that object. And so now we have the John object, right? And here is where the difference between arrow functions come in, because you cannot do this with arrow functions. So if I do const person equals to the arrow function, right? And this is valid syntax, right? We're just assigning const person to the function name age, right? But if you save this, you go back, refresh, it doesn't work, because if you use the arrow function, it doesn't have a new sort of this context. The arrow function is sort of like a lighter way of writing functions, so it doesn't really create another context, like a calling context. And so this doesn't really, it's not assigned to the object, so you have to use typical functions for this. Okay, so that's functions. Sorry, that's constructors. Another way of writing, so this is the last one, is using classes. Now I know that I said there's no classes, and technically there is no classes, but this is a syntactic sugar, which means it's really just a better way of writing constructor functions. Under the hood, this is exactly the same as constructor functions. There is no such thing as classes in JavaScript. So we're going to do class, person, and inside this class, we can actually type in the constructor. So to write the constructor, we literally write constructor, and then the variables, and then this.name equals name, age equals age. Okay, and then now in here, we can actually create methods, but I'm not going to do that. And then it's pretty much the same thing. We just do const John equals to new person, John and 20, console.log, John, and this will work, right? So this, again, this is just an easier way of writing constructor functions. So this essentially this whole class is essentially just a constructor function, and you can see why, because it's used exactly like a constructor function, right? So you can also create methods in this class. So you can do introduce, and you can log console.log this.name, right? Oh, just print out the name, I guess. So, and then you can call that, so john.introduce. This will print out the name. Go back, refresh, and you'll see. Okay. So if you want to create methods with the raw syntax, by the way, you can still do that, by the way. You can just do like for example, I can do introduce property is a function. Oh, don't use the arrow function because we need this. So function log this.name, right? So I know, very wonky syntax, but you can kind of see what's going on. The introduce attribute is a function that logs this.name, and don't use arrow functions because we need this, right? Okay, so that's essentially object creation in a nutshell. So there's two ways of doing it. There's raw, and there's the constructor functions, and then there's using classes, but classes is essentially syntactic sugar for constructor functions. And I went over methods just now. Okay, so how does inheritance work? So for inheritance, I'm going to pull out the slides. Okay, so in JavaScript, inheritance works. Instead of using classes, objects inherit from objects rather than classes inherit from classes. So the object that is being inherited from is called a prototype. So the cat inherits from pet, right? Because class is a subset of pet. So the cat object actually inherits the pet object. So pet is said to be the prototype of the cat object, right? So if you actually go into the logs of the objects, if I go back to the code and actually log the object, console.log John, right? You'll see here that there's a prototype, and then here the prototype is object, which means this object inherits from the prototype of the object. It's sort of like a global object. But you can sort of imagine how inheritance is done. I'm not going to go too much into it. You can look it over yourself. But that is sort of how inheritance is done. Instead of typing every single attribute that you want to inherit from, you can actually inherit certain objects attribute rather than inheriting classes. So it's not as strict as Java. But most of the time, if you're just writing spaghetti React code, you're not going to even need to know this. But it's just nice to know. Okay, destructuring is something that you need to know, especially for React. So destructuring is a syntax that allows us to basically extract certain parts of variables. So we can do array destructuring. So if I create an array, 1, 2, 3, 4, and then I can actually extract out only the first two values and then assign them to two variables with one line by doing this. Const first num, second num equals to my array, right? This will basically destructure my array, and then because you've specified two variables, it will extract out the first two variables and assign them to the variables accordingly or respectively. So first num will be 1, second num will be 2. First num, second num. Go back, refresh, 1, 2, right? So this is sort of how we destructure arrays. To destructure objects, so I'm going to comment this out. I'm going to create an object, person equals to age 20, name John. I can extract out certain properties of that person. So I can say, I don't want that object, I just want the name attribute. And I'm going to assign it to the variable called name. To do that, the syntax is pretty similar, right? Curly brackets name equals to person. It will destructure that person and take out only the attribute corresponding to what you just typed. And I typed a name. So it's going to extract out the name, and then you can log it. So if I console.log name, it would just be the name. Am I doing this wrong? I'm not doing this wrong. Why does it do this? Whatever, it works. So you see here that it prints John because I destructured the name out of that person. This is so weird. Oh, because name is a special keyword, okay. Let's do like name, whatever. But there's nothing like technically wrong with it. It's just the name is a special word. Okay, so that's sort of destructuring, and this is a syntax that you have to know when we're doing React. So, okay, we're almost there. Async, DOM. Okay, async is the hardest one.
Gavin,
Yeah.
question.
Yeah, what's up?
So,
Oh.
you know how you like you took out like the first two of the array? How would you take out like 2 and 3 or 3 and 4?
You make more. So,
But like, what if you just wanted like 2 and 3 in particular, like the ones?
oh. That's such a good question.
Like, did you just like leave lines? Yeah.
I guess. I have never done this before. So in React, you're going to see that you want to, the thing is like you never need to do that, right? It's like you never really want to do that. You just use the index. Destructuring for array is sort of like, oh, I want specific indexes to be a variable that I can reference later on. So it's not really meant to like access a specific value that is later on in the chain. To do that, you just use index. Like if I want the third variable, it would be pretty stupid for me to say, okay, I want the third variable of the array. Let's destructure all the way from the beginning, right? Okay, so, okay, I'm gonna comment this out. Okay, asynchronous programming. This is gonna be so complicated. Hopefully I can explain this. Okay, so asynchronous programming is a method of writing code that allows tasks to run concurrently without blocking the main thread. What that means is that it creates sort of the illusion of running multiple things simultaneously. And the reason why this is important in JavaScript is because if you're running, as I've just sort of demoed, if you run something and it just sort of gets stuck on that thing, the page actually lags because there's JavaScript that needs to be run to sort of load the actual web page. So if certain things get blocked, like you're requesting from a server or you're doing anything that will take a while, you don't want the actual page to freeze. And so to solve this problem, JavaScript allows you to basically hand off certain tasks to the browser API. So browser will take care of something like requesting to the server or creating expensive computations, right? It would sort of allocate that task to the browser, and then JavaScript can just keep on running. So what all JavaScript does is it allocates expensive tasks to the browser, and then it just keeps on running. So that's asynchronity. So it creates the illusion that it's running multiple things simultaneously, but actually JavaScript is always running one thing at a time. It just allocates certain things to the browser. So, okay, so this is how the web works, right? So this is from week 1. Whenever you request a website, you're making an HTTP request to a server, and the server is just a computer. And the computer responds with the HTML, CSS, JS files, and then your browser sort of takes these files and it renders the graphics and run the code. So when you're making that request, it can take a long time. So when you're fetching that request, you want that to be asynchronous. You want that to sort of run on the browser in the background, and the rest of your JavaScript file runs. So if you're fetching something, you're gonna have to use asynchronous. So this is sort of like where sort of all happens. So if you have the JS engine, this is the thing that actually runs JavaScript. This is the call stack, right? So if you're calling multiple stacks of functions, that's the call stack. Whenever you run certain asynchronous tasks, it just allocates it to what's called the web workers API. And then the browser is responsible for that. This is the browser. The browser runs that. The browser is typically written in C or C++. And so the C and C++ code runs that in the background, and then you can sort of keep on running the JS in here. And then whenever that thing gets done, it just sends basically just says that I'm done and that the result is in the task queue. And then whenever this call stack is empty, right? Whenever I'm actually done running the entire JavaScript file, then I'm going to look in the task queue and see, oh, there are some tasks that I handed off to the browser that is actually done. So now that it's actually done, I'm going to take the result of that, and then I'm going to actually do something with it, right? So that's sort of how it works. JavaScript is always running one thing at a time. JavaScript is a single-threaded language. So that's sort of how it works. So in code, it's actually a little bit complicated, but it's very important to understand. So I explained this. Okay, so the typical way of doing asynchronous programming is with callback functions. And callback functions, and this is very wonky, but you can actually pass in functions as inputs to other functions, right? So you can do a set timeout. Set timeout is a default function in JavaScript, right? I can call that. And then this function takes in two variables. The first variable is the function that will be called after that timeout, right? So if I just console.log hello, right? So that's the first variable, right? The syntax is a little wonky, but we have the set timeout. The first input is the function that logs hello world. The second input is the amount of milliseconds you want this to delay it by. So maybe I want 3 seconds, so 3,000 milliseconds, right? If I do this, go back and refresh, 1, 2, 3, and you'll see hello, right? So this is asynchronous because the timer is running in the background. So I can actually just print something here, right? Outside timeout, right? And even though JavaScript will read this first, it will pass the timer to the browser, let the timer in the browser time the 3 seconds, and then just move on and just print this. So you actually print outside timeout and then print hello world, right? So if we go back outside timeout, 2, 3, hello world, right? So you'll see here that we can actually achieve asynchronous tasks with a callback, and this is called a callback function. It's called a callback function, I guess, because I just give you this function and you can call it back later, right? So that's one method of doing callback, one method of doing synchronous or asynchronous programming. And these things depend on the API, right? The set timeout wants you to do it the callback way, so you just have to do it the callback way. So, so that's one way of doing it. This is sort of easier to understand. But another way of doing it is with promises. So promises are a type of object, and promises are objects that represent a task that will eventually be done. So to explain this, I can create a promise. So const my promise equals to new promise. Promise is a global constructor. And then in here, I can actually type, the first input, it's the executor function. And the executor function takes in a resolve function and a reject function. And this is an arrow function. So we have a constructor. The constructor takes in the first input, which is a function, and that first input function takes in a resolve function and a reject function. And in here, if I just type in resolve, and then in that resolve, I pass in the data, what this means is I have a promise that will basically resolve instantly with the data, string data. So if I actually go in here and I print like outside, I guess, promise, right? The outside promise will print first, and then it will print data because there is a my promise that will resolve instantly with my data. So it passes the promise to the browser instantly resolves it with data, but even though it instantly resolves it with data, JavaScript has already moved on to the console log. So if I go back, you can see outside promise, and why didn't it print and resolve? Oh, sorry. So with the promise, you have to specify what you want to do with that promise's data afterwards, right? And to do that, you type in my promise, so the actual promise object, and you call the .then method, so the then method. And the .then method is will take in a function that takes in the data that is returned or resolved from that promise. So I'm just going to call it data, arrow function, and I can log data. I'm just going to log data. So we have a promise, right? The promise promises to actually get something done in the background, and that thing will just simply resolve instantly with the data. And then I log this, and then I specify that with the my promised promise, I want it so that when it's resolved or when it's done running whatever it's running, I want to take whatever it returned, and I'm going to log it, right? Even if I do this before the console log, this simply specifies what happens after it's done. It doesn't actually do it. So if I go back, refresh, you'll see here that outside promise prints first, and then data prints, because this just sort of resolves instantly. So this is how promises work. Most of the time, you won't be creating promises from scratch. You will be sort of using promises. So you just have to know whenever you're doing something, certain things are promises, and which means they run in the background, they run asynchronously, and you want to use the .then method to specify what to do after it's done. So there's still a ton to explain with this. For example, the .then actually returns another promise. So I can actually put another .then here. So if you imagine another synchronous thing running here, right? You can return the data. If you return from here, you'll return another synchronous data, because the fact that this is asynchronous means that what's in here is also asynchronous. So if you return another data, right? This will return another promise that will eventually give you the data of another data. And then you can do another .then, and then do the exact same thing, and then print data, and it'll be another data, right? This is getting kind of confusing, but is everyone following? Raise your hand if you're confused. That's good. Okay, so that's promises. Let's actually use promises. Oh, sorry, we got to do async await. So async await is exactly the same thing as promises. It's just syntactic sugar. It's just easier way of writing it. So instead of like writing promises and then using the .then method, we can actually use an async function. So async function is a special type of function. So if I do async function task, whatever. And inside this async function, it's a typical, just normal function. If I print hello world, right, and I just call this function, it will just print hello world. There's nothing asynchronous about it so far. But the only asynchronous part comes in when you do await. So if I do data, or const data equals await my promise, what this means is the await keyword is the .then, right? So everything from here and onwards is the callback of the .then, is asynchronous, because I have to wait until my promise is done resolving. And then when it's done resolving, I'm going to take the data that whatever the promise returned, I'm going to store it in data. And after this line, I can use the variable data. But you have to understand that here, what's below await is asynchronous, which means it won't run immediately. It will run only after my promise is done. So when you run task, it will run everything synchronously, it will print hello world, and then it gets to the await, and then it's going to say, oh, okay, because the await is awaiting my promise, so I'm just going to pause the function from here. It doesn't actually pause, but it kind of pauses from here and just jumps out of this function and then prints the rest, right? So it waits, it's jumped out of this function, prints the rest, right? And then whenever the promise is done, it will actually then log data. So if I refresh, you'll see here that, so you'll see here that you first declare the function, and you first run the function, and when you run the function, it prints hello world, right? So you see print hello world, and then const data equals await my promise. Oh, my promise is an asynchronous thing. I'm just going to wait for that. I'm going to jump out of the task. I'm going to delegate it to the browser. I'm going to log this, which it logs this, and then when it's actually done, which is done instantly, it looks at the task queue, and then it actually prints the rest of the thing. So when you actually return something from an asynchronous function, it's actually returning a promise of that data. So if I do const more data equals to task. So oopsies. So a normal function would just be like, oh, you instantly get that more data as more data because you return it, right? But because it's below the await, what's here is asynchronous, which means the output of this is also asynchronous. So instead of getting the actual data, you have to wait for it, which means it's a promise, right? So more data is a promise. You can actually do more data, and then you can specify, okay, after this promise actually gets some data, I can print that actual data, right? But if you don't specify this, more data is not an actual data, it's a promise, right? So, so for this, it will run this, log this, await this, jump out of the function, print this, and then whenever this gets done, it prints the data, and then after it prints the data, it returns this, and this gets the data, and then this runs this, right? So kind of confusing, but hopefully that makes sense. So that's the async await. Nothing is special is going on behind the scenes. You can just treat it as await is just another .then, right? What's below here is just a .then. It still uses promises under the hood. So that's async await and asynchronous programming as a whole. And then last thing we need to cover is DOM. So the DOM stands for Document Object Model, and it's essentially a JavaScript object that is supposed to represent the actual HTML document. So the DOM is a programming interface that represents a web page structure as a tree of objects. It allows JavaScript to access and manipulate HTML elements, styles, and content dynamically. And through DOM, web pages can change interactively without needing full page reloads. So, right, you have an object, right? This is a tree. And this tree, like we have this little node, which points to this node, which points to this node, and so on and so forth. It's a JavaScript object that represents the actual thing that's being rendered on the HTML. So we have the actual document object, and then the HTML tag. And then in the HTML tag, we have a head tag and then a body tag. And in the head tag, we have the meta tag and title tag. In the body tag, we have the H1 tag, H2 tag, and so on and so forth. This doesn't necessarily have to be a binary tree. It's a very messy tree. So, because you can imagine body has more tags. So it's basically a tree in JavaScript that you can access and link into and actually change the content of the actual HTML document. So this is where it gets fun, because this is where it can actually use JavaScript to change what's on the website. So instead of using the console, now we can actually edit stuff. So let's say I want this H1, right? So if I go to that H1, that's the H1, right? And I think this is the only H1, so I'm just going to select H1. So I'm going to comment this out. To select a document, or sorry, to select a tag from HTML, you have to assign it to a variable. So I'm going to do const title equals to, and I'm going to do document. Document is the actual structure of the document, right? The DOM thingy. Dot. Get element. You can do get element by ID, and then you just have to type in the ID, which I'm going to do, like, I don't know, title, right? I'm going to go back and make the ID here, title. So we have ID of title, and then I'm getting that document object with the ID of title. And title will then have certain attributes, like text content, which is supposed to represent what's inside that tag. And I can say it equals to hello world. If I save this script, I go back, it will first be hello, I'm John Pork, and then it will be hello world instantly. Right? So that's sort of how you edit it. If you don't want to use ID, or like use the get element by ID, a more generic way of doing it, and this is how you'll be using it most of the time, is a query selector. So document.querySelector, and this is a more generalized way of getting documents. So just like in CSS, for ID, we just specify hash, right? Hash title means we want to get the ID of title. If we go back here, refresh, same thing. But if this is a class, right, you can still use the same function, except instead of hash, you use dot, which will be the class of title. still works. In fact, if you don't want anything, right, just H1s in general, every H1, this will actually return a list of, I think so, yeah, a list of H1s. So I'm not even sure if this will work. Well, I guess it works. But yeah, anyways, so query selector is what you'll be using most of the time if you're selecting from an ID, hash, if you're selecting from a class, period. So that's how we manipulate the DOM. And then because we can manipulate the DOM, we can actually fetch from certain APIs, and then these APIs will respond with data, and then we can update the DOM through the data. So if okay, so this is the actual, what's on the GitHub right now, week 4, or week 3 rather. And so it's essentially, I guess, a div here. And then initially it prints loading. And then it fetches, the JavaScript fetches from an API. The API responds with data. And when it's done responding with data, so it's an async thing, it will grab the HTML element and then just replace the content with the data. So if I go back here, right, let's say I don't want to do the styling, but just let's say I want to do this div, right? Hi. So let's say I want it here, right? So this div is going to be joke. It's going to store the joke. And then in the script, I'm going to call the API. So this is the source code of the actual website. If I go zoom in here, this is the API link. If I copy this link, you'll see that if you paste it in the browser, you'll see here that the browser sends HTTP request to the actual API, and the API responds with a JSON. JSON is just a data structure that resembles the object syntax of JavaScript. So JSON, we got error equals false, category pun, type single, and then the actual joke, the whole string. And then we have certain flags to set to make sure that this joke is PC, I guess. And then language, English, stuff like that, right? So we want this object. Every time you refresh, it gets a new joke. So similar here, every time you refresh, it gets a new joke, right? So we want to fetch from this API. So we're going to copy that link, go back. I'm going to do const. If you can't find this thing, I think you can just Google joke API. And just search whatever API is public. Some APIs obviously need you to sign up because they don't want you abusing their servers, but a lot of APIs are actually free. But anyway, so this link is the API. I'm going to actually fetch from that API. So fetch is another function. So fetch from that link, right? And then after I fetch from this link, the fetch function is actually it returns a promise. So when I fetch this, it will return a promise. Like I said, fetching from something takes a while, so it's not going to block the main thread. And then, so because it is a promise, I have to do a .then. And then I'm going to, inside the .then method, I'm going to pass in the function that will execute after I get the data. And this function will obviously take in the data. By the way, you can name this anything you want, right? This is just an input. And then in here, I'm going to do console.log data, just to see if it works. If I go back and I refresh, and I look at the console, you'll see here response, and then we actually have does it work? Oh, sorry. Okay. When we get the response, it's actually not the data itself. It's actually just the headers. Because when you fetch from certain APIs, it may take a while for that data to stream in. So instead of getting the whole thing, it will respond with the response with only the headers, and then it will wait for the body to load in afterwards. So what we have at this point, I'm going to call it res because it's actually a response. What we have at this point, res is just the header, the HTTP header. And to get the body, I have to use this, but the body is not streamed in yet totally. So we have to actually do another asynchronous task, which is waiting for the fact that the body will actually come in. So to do that, and because body is a JSON, we're going to do return res.json. So res.json, this JSON method, will expect that the response will be in JSON and will parse the JSON into an actual JavaScript file. And this is asynchronous because it needs to wait for the whole body to finish streaming in before you can actually call this or get the actual data. And so I'm returning this, and because this is a promise, and so I can do a .then because this returns a promise, and inside the .then I can finally get my data. So then I can console.log data. And a better way of writing this, just so it's more readable, is you go to the period. What is happening to my machine? Oh, there you go. Yeah, you go to the period and just type in .then after that, just so it's slightly more readable. And then it will work. So you actually have the actual JavaScript object, and you'll see here that we have a lot of attributes, one of them being the actual joke. So now the rest is easy, right? Instead of logging it, I want to get the document tag, so the ID of joke, so document or const joke div equals to document dot query selector hashtag, which is the ID joke. I'll go back, yeah, ID joke. And then I'm gonna do joke div dot inner, not inner HTML, text content equals to the data. I save that, go back. And instead of loading first, it will say hi first because originally it was hi. So refresh. Right, of course, because data is the actual object. So it's data dot joke, I think. That's the attribute. So you have the actual object, and then I want the joke attribute. Yeah. So there you go. And then you can imagine that this is just more styling. This is always John Pork, by the way. But anyways. So if you want it initially to be like loading, then you just make this loading. You can even make this a loading spitter, right? That's just more HTML, CSS type stuff. So refresh, and you'll see that it works. So very simple, extremely simple, but you can see how this scales in a bigger application, right? So you just manipulate a bunch of DOM thing and it'll be displayed. Okay, so wait, what else am I going to say? I think that's pretty much it, yeah. So that's how you fetch. Oh, eventually, when we build the CMS, just for you to understand what we're building, we are building something like a application on the server that exposes the API endpoint that allows the front end to fetch data like this from the backend. So we're going to eventually build the backend that allows for this data fetching. We're going to actually build this, basically. So that's what we're going to do when we're doing the backend. But this marks the end of all of front-end development. If you know everything up to here, HTML, CSS, JS, everything else is just an extension from everything that I've just said. So that's pretty much it for front-end. Hope to see you guys on the 4th week.